Yeah.
I specifically asked to not do that.
Thank you.
The freezer is bad.
Yeah.
Can I borrow that? Can I borrow it?
Borrow a calculator? Yeah. We're just going to do a little bit with these.
I'm so hungry.
I wish it said Sega. Sega. Oh. Hopefully it turns on. You know if your calculator turned on or not. Let's see. There's the computer. It's amazing. All right, let's take a look. So I got two calculators here, and that is right as shit. There we go. Okay. So there's our TI. I'm going to start with this dude because I think I know the ones that just borrow one have this one. How many of you guys have one that sort of looks like this? Remind me? Anybody? One that sort of looks like this? Do the rest of you have a TI calculator?
I don't know what this is.
Intriguing. Okay, okay. So it has, what are you? Who's not sure what they got?
Me.
Oh man, my battery's low. You.
Sure.
Dude. That's my calculator.
X260 solar too.
Oh, that's too bad, Jeff. Too bad. Do I have this one here? Yes, I do. Okay, okay. Do this one at a time.
So
Do it live.
light.
So there's a couple of functions on your calculator that you might not be aware of. Do you guys know about the? Oh, it's a gas. Yeah. Okay, they're always fun. All right. Yeah. Okay. We'll see. You might have a couple that look a little different and are in different places, but. By the way, I don't own stock in Texas insurance. I don't care about that. So there's a couple of things I wanted to point out. Let me see. I wrote myself a little outline so I didn't forget anybody. But I forgot the outline. No, there it is. Okay. So one thing is the parentheses. How many of you guys ever use parentheses in your calculator? You guys? Okay. So you do have parentheses on your calculator. If you're not sure, if you can't find it, let me know. But they do exactly what you would hope. So if I did 7 times parenthesis 8 minus 5 close parenthesis, what should I get? 21. Yeah. Because you do parentheses first. So these do understand order operations. Right? Yeah. Okay. Does anyone have a calculator where when you type things in, you can't see everything you've typed? Anyone? All right. So you got the really basic ones. All right. Good luck. Those kind of stack. And again, just to remind you guys, you borrow this, or these are $15. Who's bought one like this? Is that around $15?
Yeah, it's all
No, I understand. At the same time, I don't want to sound all like let them eat cake or something. You know, $15 might put somebody out. I remember those days. I remember scrounging for change in the back of my car, like maybe I can get enough gas to get home. So I know $15 could. Yeah, this was young Jeff had a rough time. So thankfully we got 21. Or if you wanted to do 7 divided by 8 minus 5, you're going to get a different answer if you do 7 divided by 8 minus 5, of course. Right? If I don't put parentheses in, what does this tell me to do last? Subtract 5 last, of course. Okay. So just want to make sure you guys are aware of the parentheses. They actually are useful. You just got to be careful. It always gets interesting when you have multiple parentheses going. So I could have parentheses 7 minus parentheses 4 minus 6 close parentheses, plus 2 parentheses squared. Holy shit. So you gotta make sure that as you open parentheses, you end up closing them eventually, right? And that gets a little bit daunting. Now, in this class, and obviously in elementary school, you're not gonna get long ass equations with multiple parentheses happening too often, right? Anyway, just out of curiosity, what is that? 120, of course. All right. Now here's something kind of neat. Everybody on whatever calculator you got, hit 3, then do times 3. Let's see if this works. Hit enter. No, that's not how it works, Jeff. I forget now. Oh, I see. I remember now. So times 3. There it is. Okay, okay. So do 3 times 3. You get 9, correct?
Yeah.
Now do times 3. And what does it say when you just hit times?
Answer.
So even on a TI calculator, it should say answer, right? And does anyone know what that means?
The answer before.
Yeah, the last answer that showed up on the screen. So if I wanted to do 3 to the 7th power, so far I've multiplied by 3 twice, right?
Yeah.
So if I just keep hitting enter, it's going to continue doing this. So if I hit enter, that's 3 times,
Yeah.
4 times, 5 times, 6 times, 7 times. All right. So it kind of has what's known as an iterative algebra. So it can kind of build on what was already there. Yes?
Are these at the bookstore?
Say again?
Are these at the bookstore?
I don't know. I almost don't want to tell you to go there because they mark everything up a stupid amount. So it'd be better to go to Staples or something, but at the same time, if you give the bookstore money, it'll make its way to me, so go buy many things. No, it's bullshit, it's bullshit. Yeah, sorry. Sorry, I'm not towing the line. All right. What about, so of course, there's gotta be a better way to freaking do 3 to the 7th power, right? Do you guys know where what I call the to the button is? What I call the to the. Yeah, so a lot of you guys, it should be a little caret. Some of you guys, let me see, what is mine? I don't have a clue.
Right
This
there.
is not the one I normally use.
On your left.
Oh, there it is. There's my to the button, 3 to the 7th power. Do some of you guys not have the little caret?
Yeah.
Do you have a button that says like X to the Y or Y to the X?
Yeah.
Yeah. So be it 3,
Oh, yeah.
then try this 3, hit that button, 7. Enter, or equals, yeah. There you go. So your X to the Y is your to the button, right? And by the way, I could be doing it side by side, but you know, I don't know what the hell I'm doing. Oh yeah, that's right, you're dead. I can't do that. Now I remember what I'm doing, okay. All important clear button. What else do I want to tell you about? Oh, memory keys. Probably the most important memory key is answer. So on this calculator, the answer button is right there. On the TI, it's in the same place, if I remember correctly. And I don't know, if you don't have one, I'm not sure what to tell you. But for example, if we do, everybody do this. 7 minus 8 divided by 17. Okay, now let's say I wanted to take the square root of that. Right, so where's the square root button? On my calculator, it's right above the x squared. It kind of makes sense. They put like inverse functions together. Can you guys all find your, you know where your square root buttons are?
Yeah.
Okay, I like it. So if you hit the square root button, so for me I gotta do second x squared to get up to the square root, and then I tell it second negative, so I get answer. Then it'll take the square root of the last thing on the screen. Kabam. So to me, that's like, you shouldn't necessarily need multiple memory buttons, but if you have a TI, you got a number of memory spots. This calculator, I don't remember. I don't use this calculator much. You have memory spots somewhere. There's memory variables. So yeah, you can access memory variables. I'm not going to do too much with that. Yeah, I think that's plenty. play. I was gonna say, well, watch this, everybody. Do this. 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Right? Times 9,000. What do you guys get?
6.3 to the 13th.
I guess I put
I got
too many
13.
zeros.
1, 2, 3, 4, 5, 6, 7.
6.3 exponent 15.
That's okay. If you miscounted your zeros, that's fine. But does everybody get basically, now this one's kind of neat. This one has a little times 10 to the right there.
Mm-hmm.
Some of you guys, like the TI has a little E, yes?
Yeah.
You guys see the E?
Yep.
Because you know the answer is not freaking 6 something, right?
Yeah.
I love it when students just put, it's 6.3. What? So the little E, dude, it's just, the E stands for times 10 to them.
Yeah.
Kind of like it. So when you have something that's overflowing the size of the screen, the calculator has to give it to you some way. And sign notation is a beautiful way to condense a number. So you guys, okay? All right, okay, just wanted to point out a few really basic things about the calculator. Any TI people, do you have any questions about your TI? Well, I have it up on the computer. Let me just real quick.
I don't think I use it more than that. Yeah.
So here's what it basically looks like.
Oh,
See, there's your,
I have
yes?
a question. Okay,
Yeah.
so I know sometimes for the TIs, you have to be careful on how you're the mode or like the settings are set up, because sometimes if something changes, it'll affect
Oh yeah.
your answers.
One of the most common settings that freak people out, if you hit the mode button, the most common one is this guy. See where it says float? And you're like, oh really? It'll make me a float? No, but if you pick like a number, it'll always round to that many decimal places. If you do float, it'll just always give you as many as it can. So that's the most commonly mixed up mode. These other modes don't really mean too much to us. This is like trigonometry stuff here, right?
Yeah.
Angle, degrees, and I don't know how many of you guys know radians. You guys know radians? Some of you guys? There's scientific notation. There's engineering situation. This is all about graphing stuff here. And then, anybody know what this is?
Is it with dealing with imaginary numbers?
Yes, these are complex numbers. Don't worry too much about that.
Okay.
But yeah, normally when I tell a student who's just starting with a TI and they're in a basic kind of math class, I just say make sure all of these on this side are highlighted, right? The minute you start highlighting something in here, things could get freaky. Yeah. Anything else about the TI while I have it up there? Okay. You guys are like, don't ask questions. We're gonna leave early. Okay. I'm not blaming you. All right. So that finishes up section 4.1. What we're gonna do, I bet you never would guess this. We're gonna get into 4.2. And 4.2 is all about building our standard algorithms finally. What do we know so far officially in this class about division? Same kind of idea as multiplication, right? What do we know about division? Repeated subtraction, right? That's all we know. Now, at the same time, just in general, we know how to long divide. So we know that exists. But you have, again, it's all about structuring things to get a student to a point where they will actually understand what that represents, right? So we're going to do a few building of basic algorithms. That's true. That's why. Oh, that's true. All right. That's all right, Jeff. You'll be fine. There are some manipulatives. Let me think. Do I need to use them today? Maybe. We'll try to draw some stuff first. See if we can get away with it. So the first algorithm we're going to do is we're finally going to do the addition algorithm. We don't even have the carrying a 1 yet fully. We haven't established that algorithm yet, right? Start off with So happy I spelled algorithm correctly. So let me ask you, all right, see if you guys are cool with this. Remember our base 10 pieces? Okay. To save me from dragging out all the base 10 pieces, what were the shapes for base 10? What did they represent? Who remembers? Or any of the base, we had base 3 before, and then I used base 10 up here. What were the pieces called?
Long. The long with
The longs, I like it. So you got the longs. Let's just represent a long like that. Is that cool? Just to save time. This is a long. What does it represent in base 10? 10. Because it's 10 what's? What's a long made of? 10 little units. 11. So unit is 1. Long is 10. So a unit will have to do a little square. We'll be okay. Is this going to work? Yeah, this will work. And then what's the big dude?
Flat.
Flat. So we'll make a big square, flat, and that of course represents 100. And why does it represent 100? Why? How tall is it? How many units tall? 10. How many units long? So it's one of these by itself, and then when you multiply to get the area, you get 100. It's crazy. And again, this perfectly captures how our base system kind of builds by factors of 10. Okay, let me stop for a minute. You don't have to stop. I'm just going to stop. It's not red light, green light. No, none of that.
That's what I thought of too.
Yeah. So if I had to do something like, let's start off something where we don't have to draw too much. 16 plus 25. So what do we have to draw for 16?
1 long and 6 little cubes.
All right, my little cubes are going to look like triangles sometimes, too bad.
And then
25 will be
2 long.
2 longs. Someday I'll come up with a better little system. All right, these guys, they melted, okay? I left them out in the sun, leave them alone. So visually, if I add these together, it really is just, and again, you can see why I want to get the manipulatives out, but we should be able to handle this. You can have 16 sitting here, right? A long and 6, and then you can have 25 sitting in, and then you just bring them together, right? So for a kid, first learning this shit, it starts based on counting, because that's the very first thing they learn with mathematics is counting. So you just bring them together and they can count the answer. But what's going to happen? So if I just purely add these together, don't I get, how many longs do I get?
4.
How many longs do I get? I get 3. Don't get ahead of me now. And how many little cubes do I get? 11. So what do I do with, how many little cubes of course makes a long? 10. So if I circle 10 of these guys, I can make this. I think that's what you probably did, right? And of course, how many little cubes are there? 1. What does that mimic in our standard algorithm for addition? Well, we just did this. What does that mimic? Well, what's our standard algorithm do? 25 plus 16. We do it the same order. What's our standard algorithm do?
Carry that.
6 and 5 is 11, so put a 1 down. Carry the 1. Carry the 1. That's the one that we carried. So they have a physical baseline. We haven't even shown them this shit yet. Which is what people are like, oh, why are you doing all this shit? You just show them this. No, they have to understand what this means before you can show it to them. So this is a physical baseline. So when you show them that, you can say, think to yourself about the flats and the things, you know, so they continue building on what they're comfortable with already. So now I'll get my 4. Yeah. So here's the 4T1.
yay!
We did it, guys. We added 16 and 25. Okay. So, I want you guys to take a minute. Let me see. Yeah. All right. Can I erase all this? Are you guys ready? Yes? Okay. 171 plus 253. Not too bad. With the base pieces, right? Try to draw that out. Very happy. Now, of course, something very similar is going to happen, right? So what happens? What happens?
10 of your longs and total.
Yeah, so if I collect, here's 7, so if I collect 3 more, so I have 1, 2, 3, and then I'll carry this one. So then how many longs are left? 2.
4.
Yeah. So that's 424, which thankfully is the right answer, right? Does this feel a little bit like another civilization, right? Right? And you got the little Pac-Man and stuff. Why can't we have boxes and freaking whatever, right? Okay. So 424. Yay! Now, just to show you, to move in the direction of the standard algorithm, one thing you do, and this is what the book calls the intermediate algorithm 1. Oh my God, it's just, sorry, it's a little insane. So kind of the first step towards what we do would be very simplistic. For intermediate, this is not algebra, algorithm 1. You add the ones. Amazing. Then you add these. This is 70 and 50, right? You guys see that? 1 and 3, 70 and 50. And then 100 and 200. You stop for a minute. You guys with me? Do you see how that really is sort of one step away from the standard? Again, where's the carry part? Because 7 and 5, did they stay in their lane? Right? 1 and 3 stayed in its lane. 7 and 5, what the shit? So it kind of spilled over into the next one.
Yeah.
So depending on how you want to, you probably don't want to go, what the shit? With a bunch of 5-year-olds or whatever. But this is kind of beautiful if you think about it. And they know what these represent. They know this represents 100, 70, 1, right? So you can, so 70 and 50 is 120, and then you can show them visually, look how that 1 came over and that matches with what we did physically,
Yeah.
right? So then you get your 424. It's crazy shit. What the shit? Now the book does identify a step 2 before it gets to standard, which I think is really silly. Step intermediate algorithm 2 would be, where you go 1 and 3 is 4, 7 and 5 is 12, and 1 and 2 is 3, and you just don't put anything here, and I don't understand that at all. It doesn't make, to be really honest with you, I don't. Because we normally put zeros here, don't we? I mean, that's just part of what we do. But then the actual standard, of course, just to make sure we all remember what that is after we talked about all this other shit. The way we standardly do this is 4, 12, carry the 1. But now they have a couple of things to look back on to see why they make sense. That 1 does sneak over. It sneaks over computationally. It sneaks over visually. Maybe? Because that carrying shit is weird. It's just weird. That's why you want to build to it. Now you want to talk about something weird. I want to ask, let's do this one more way. The same problem. We're studying the shit out of this problem. Let me see, I'm just going to set this up and I want to see if anybody's ever done it this way. I gotta remember how to do it. It's not a way I normally do this. One plus 3 is 4. 7 plus 5 is 1, 2, 12. 1 plus 2 is 3. Then you add diagonally. 1 plus 3 is 4. 0 plus 2 is 2. Has anyone ever seen anything like that? Yes?
Is there a name for it?
Yes.
What's it called?
Lattice method.
Interesting.
Right? Not the lettuce method. But obviously it's because, you know, lattice that you can get for visual display. Kind of looks a little bit like that. There's also a lattice method for multiplication we'll talk about later. Yes?
Are we gonna use the lattice method?
Yes, I might ask you, there will be in the homework, and I might ask you in a quiz or something. So let's do another one real quick. Let's do one a little more interesting. Let's do 598 plus 375. Try to do that. So feel okay? Is it too cold, too warm? Okay. I'm always too warm, so I'm okay with it still on. So let's see how does this work. 8 and 5 is 13. 9 and 7 is 16. 5 and 3 is 08. So you get 9, 73. Crazy. And of course, real quick, just to remind you, we're of course smarter than this shit, right? Obviously. But couldn't I make this 600? If I make that 600, this has to be 373. And I should by me, right? I like it. That's that compensation idea, right? Taking some from somebody and giving it to somebody else. Okay. All right. So a few of you guys have seen that lattice method, it seems. Yeah. Okay. Let's do this. Let's look at subtraction real quick. Let's just. I always wonder what's going through your heads if you're sitting there going, we're doing a deep ass dive into adding and subtracting. That's what we're doing. So what about if I had 423 minus 157? Let's do this visually. Visually. So go ahead and set up the base 10 pieces for those. Lost track. There we go. Whole thing. All right, so subtraction. Again, imagine, in fact, if you were really doing this on a table, you wouldn't have this. You would lay this out. And then how do you think I'm gonna, if I had it laid out on a table and had this, I just put this here for reference, but if I had this on a table, how would I subtract 157 away? What would I start to try to do? I could take 100 away, right?
Yeah.
I still have to take 50 away and then I run into a problem, yes? Okay. And of course I'm gonna run into a problem with 7. Shit.
Yeah.
So what idea are we starting to lay the groundwork for now?
Breaking down the base.
Starts with a B, and it does relate to that.
Borrowing.
Borrowing, I love it, but you got it, that's what borrowing is. So so really this isn't really sitting here, this is just here for reference. I have to be able to find this in this. I got plenty of hundreds, so I got no problem. I can take one of the hundreds and do shit with it, because I got plenty of hundreds that I can take away, right? So let's take one of the hundreds, of course, and do what with it?
Break it down into 10 more.
Break it down. So if I take this 100 and write that as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I got a bunch of 10s. Now looking ahead, I'm also going to have a problem because I can't find 7 of these. Right? So I need to do what?
Break down the long into 10 more.
Yeah, take one of the longs and break it down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Good Lord. So now I need my third color. Oh geez. This is too many colors for me. So visually all you have to do now is you can actually just kind of take 100. It's gone, right? Take it away. Are you guys with me? What's happening? Then I can take 5. Wow, 1, 2, 3, 4, 5. Take those away, right? 1, 2, 3, 4, 5. Don't, you went a little too far, Jeff. Okay. And then 7. 1, 2, 3, 4, 5, 6, 7. Now I can count what's left. What do I have left? 200. Why did you do this, Jeff? You do things so hard. 66. I like it. Is that the right answer? Yes, it is.
You're the
Now, you could do this a little bit better, probably, to keep track of what's alive, right? It's all about who's left alive. And again, if you have physical things, there's be no question. You're just going to take them out of the way. Just get rid of them. And you can see exactly what's left. So, what was it we did just now related to the standard algorithm? We did start here, didn't we? We didn't really need to, but we did. But don't we kind of need to start here when we do it this way? Yes? Because I can't, this is just 2. I can't take 10 away. Well, I could, that's weird. So if I take one of these, I could put that there. Right? And then if I take one of these, put that there. So you can see the taking one of these, you can see the taking one of these, right? And then thankfully we get 266, yay, okay. So again, you can always build towards the algorithm. Is it very cool when I say algorithm, by the way? It's just all algorithm means it's a process to do something. That's all it means. So our subtraction algorithm is just freaking borrowing shit like that, right? That's what that means. You move in that direction, but you're always building on stuff they're comfortable with. At this point, they would be comfortable with these shapes. They would be comfortable with what they mean. They'd be comfortable with putting them together and stuff, right? Okay. Yeah, okay. So real quick, what about multiplication? And then we'll head out, I think, after this. Think about it just for a second. Do you think multiplication is going to be as easy as addition and subtraction? Imagine base 10 pieces and multiplying. Do you think there could be a little more complication arising? Yeah. Yes? Because how do you, 100 times 100? What do you do? Do it! So how does this work? Let's do something not too crazy. Let's do 32 times 25. And, well, let's see. Let's see if I can draw this well enough. I'll refer you to some pictures in the book, see if they draw better than me. I think I'll be able to do this. 32, so what we're going to do, it's going to be very similar. Again, we're going to build on something they know. Visually, what have we done visually with a student at this point to talk about multiplication? Just the basic idea, like 5 times 3, for example. See again? Repeated it, I love it. Now, visually, what have we set up? What did you have to do in the quiz? What do you have to set up visually for 3 times 5 or whatever it was? Yeah, right? 3 and 5, right? Okay. So if I want to do 32 times 25, I could do 32. All right? Long, unit. And then up here I'm going to have 20. I really want this to make sense. And this is going back to when I first said how to get a flat from 2 longs, or what's a flat represent? Well, isn't a long by a long? And then you can create an area. I like it. So that's really what we're doing. So what areas do we create now if we just sort of fill this in? Don't I get this by this is going to become a flat? Do you guys understand?
Yeah.
And that represents 10 times 10 is 100? When I get another one here? Now here's what's interesting. I really want this to make all the sense in the world. This is 10 little units. So each one gets its own long. So that's why it ends up being 10 by 10. What am I going to put under this dude? Yeah, so under each one of these. And that represents 10 times 1, so many times, right? And then again, so again with this. And then, what happens here?
10.
Yeah, I get a long, and a long, and then a and then I get a long, and a long, and then a Alright, that's quickly becomes annoying, right? Can you imagine doing many of these? Once you see it, you get the idea. We're creating areas, because area is the most fundamental physical way to interpret multiplication. Right? So once I put this by this is part of 32, and this is part of 25, I create a flat. And then I just keep going. Flat. And then one thing of long. And now we just go 1, 2, 3, 4, 5, 6 so far, right? We got 600. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 10, 15, right? 19. So what's that? 190. And then I've got 2, 4, 6, 8, 10. and that becomes 800. And of course, this algorithm builds off of them learning the full addition algorithm, because now they can put that together. It's always, I keep saying this, one of my favorite words to use in this class is build. It's all about building from what they really are comfortable with, building with that to the next level of shit. Stuff. What do you call it? By the way, 32 times 25, isn't that, if I want to use compatible numbers, how would I break 32 up to use compatible numbers? What about 8 times 4? Isn't 4 and 25 nice?
Yeah.
That's 100? 800? Yay, look at us go. Okay. Although I agree, there's other ways you could do it, but with 25, you want that 4, so you get that 100. Makes everything quick. And this is not a lie. Multiplication. We're still talking about multiplication, so don't come at me. We're almost done. The intermediate algorithm 1 for multiplication. Let me make sure. Yeah. So if I do 32 times 25. So intermediate algorithm 1 would be 5 times 2 is 10. 5 times 30 is 150. 2 times 2 is 4. 2 times 20. 2 times 20 is 40. And then 30 times 20, 600. And so you have, so it's a lot like the addition thing where you sort of ignore the interplay and you just put down each piece, right? So really what I'm doing is I'm doing 30 plus 2 times 20 plus 5, right? Is that cool? Because there's my 600, there's my 40, there's my 150, and there's my 10. And remarkably enough, it comes out to be 800. Yeah, and the next step really is the standard method with the carrying stuff. So how would you do this the standard way? You do 5 times 2 is 10, carry the 10, you can see that 1 coming over into the next place. 5 times 3 is 15, there's the 15, plus 1. So again, it's again, you would do a bunch of drills with them with the base 10 pieces, you would do drills with this idea, and then you would start to do these, referencing what they did before, right? Again, it's always building on what they're used to. I'm not done, obviously, but yeah. 2 times 4 is amazing, and then 6, and then you get your all right. And we all go, yay. Blank. I think that's not a bad place to stop. Yeah. What do you guys think? No way. All right. Look at that. I did it perfect. Look at me go. All right. So don't get too disheartened if you didn't do well on the quiz. Try to identify why that might be and correct that for the future. If you're not sure what to do, just come to see me. You don't need what you remember, because if you add 1 to that, it's 1 of the 8 places, and then so you do want to show where that 2 is coming from, right? It's coming from the 3. So you're really doing 7 base 8 plus 3. So you might as well show 7 base 8 plus 1 base 8 plus 2 base 8. So you can really see that that 2 is still, it's not left over, it just hasn't been added yet, is what you mean.
Yeah, I'm gonna call out for the weekend and then go for it all weekend. Yeah, I don't know. Yeah. Really.
they say. Okay.
Thank you.
We'll take advantage of the AC for a second. But I'm gonna take advantage of the AC for a second.
Oh yeah, I don't blame you. Don't blame you. It got hot quick, man. I feel like it was a couple days ago. I was in socks and stuff and everything going to bed, and now I'm like windows wide open. Please, dear God.
Yeah, usually it's like 3 blankets. Last night was like 1 blanket.
Start with no blanket and then yeah.
1 blanket maybe.
It's crazy. All right. Oh, still recording. Hey, everybody.
The after credit.